Hey, so in this video, we're going to look at the basics of object-oriented programming in C++. This video is great if you want an overview or an introduction into object-oriented programming, or if you've got some classes in university or high school which are going to be testing you on these specific topics. We're going to be looking at classes, so like constructors, destructors, different types of inheritance, polymorphism, etc. So this is for people who already know the basics of C++ and want to get into classes and this slightly more advanced stuff. It's still a basic overview, but that's who it's for. Also, I know a lot of university and high school classes might ask you about this kind of stuff, so it's a good overview if you're reviewing for a test or you want to learn about this stuff and get an introduction. So, all right, so let's get into it. So we'll start off with friend functions. So a friend function is a function that is not a member of a class, but is allowed to access the private and protected members of that class. Friend functions are used when a function needs to access the private or protected data of a class, but you don't want to make the function a member of that class. So they have access to private and protected members. So a friend can access those private and protected members of a class, which would normally not be accessible from outside of the class. They are not a member function. A friend function is not a member of the class. It is defined outside of the class, but it is declared as a friend inside the class. And it's declared inside the class. The friend function is declared inside the class using the friend keyword. And it can also be a regular function or another class member. So it can just be a normal function, or it can be a member of another class. So we'll look at an example here. So in this example, we have this class with the class name, and we say this is just the general form of it. So we have this class and we write friend. This is the return type, and then the function name and the arguments. So here's an example. So we have this class box, and we have private width, and then public. You can call the width to you can construct it, and then it's also got this friend print width. And this void print width has access to the private variable width. So this is what a friend function can be used for. This does need to include IOStream, so this is an underline. But you can see this would print out width of the box is b.width. So normally you wouldn't be able to do this. Yeah, width of the box is 10.5. Normally you wouldn't be able to do this if you didn't call this a friend function. You can see if we do this and try to run it, it will give us an error because width is a private member of box. Let's talk about static variables and members in a class. So in C++, static variables and static members of a class are used to store data among all instances of the class, or to hold values that belong to the class itself rather than any particular object of the class. So they're shared across all objects. A static variable is shared across all instances of the class. It's a class level variable, so it belongs to the class itself, not to any specific object. And the lifetime of it, static variables are initialized only once and persist throughout the lifetime of the program. Static member variables can be accessed using the class name or via an object, but it's more common to use the class name. So let's look at an example. In this example, we have a class called myClass, and here we have a count, and this is a static int. And we have this member, this that calls count plus plus. It'll increment the count counter, the count of count, and then we have this static void display count. So this will just display the total objects created. So this is called during the construction of the object. So this is the constructor, since it has the same name as the class. So every time you create an object, so in this case here you can see object 1, object 2, object 3. Each time you create one, it will increment count, which is a static variable. So if we run this, you can see that the total objects created is 3. So this is one way to use static variables. You also need to initialize it outside of the class. So I'm not exactly sure, but you might be able to do this. Let's see. No, they must be initialized out of the line. So you have to write it like this. All right, so the next thing we're going to look at is just the general class data structure. This might be useful if you're unfamiliar with it, but basically it's just the stuff you've seen before. So you've got the class name. You can have public or private or protected variables and member functions. So yeah, I'm not going to go over this in too much depth because I'd assume you kind of understand this. So let's look at constructors. So the constructor has the same name as the actual class name. So in this case, we have a class called human, and we have this constructor. So it's also called human, and it takes in a few arguments. So it takes in the name and the age, and it will set the name to the name and the age to the age, and it'll also say human object created with this name and this age. So here we can just test it out quickly. We create this human object and this human object. So that's just a general look into constructors. Now let's look at abstraction. So abstraction hides complex implementation details and shows only the necessary features of an object to the user. It simplifies the interaction with complex systems by focusing on essential functions, reducing implementation dependencies. So one example of this is this. So you have a class shape, and you have a public virtual void draw. So this is a pure virtual function. So this basically allows this class circle, which inherits the functionality from shape, it basically overrides this draw function with its own function. So it'll say drawing circle. Even though the circle is of type shape, it doesn't call this draw here, but it calls the circles draw. So now let's look at file input and output. So file input and output refers to reading and writing from files in C++ using file stream objects like if stream, input file stream, and OF stream, output file stream. So an example is this. I'm not going to go into this because this is not extremely relevant right now, but you can read and write to a .txt file. So if you have like a test.txt, you can write to this file through your C++ code by using OF stream and IF stream. So here you can see we just wrote into the test.txt hello world through the C++ code. So you can use this code to read and write into files. Now let's quickly look at namespaces. So when you're writing stdcout and stdcin, stdos stream, things like that. So namespaces prevent naming conflicts by grouping entities like classes, objects, and functions under a name. So std is the standard namespace in C++. And so if we look at this, when you see out hello world or anything, you often see people writing std : cout. Alternatively, you'll see people write using namespace std, and then this allows you to just write things like without writing the std : because it assumes you're just using std. So you can just write cout like this without having to write std : generally try to avoid this because it's not good to use this namespace for the entire piece of code. there are ways to do this better, like having a specific scope for a namespace, but we're not going to get into that here. So now let's look at functions on objects. So member functions or methods are functions that operate on objects of a class. So I'll paste in this code example. We have this class student, and it has a private name and age, and it has a public set info and display info. So we can create a student here, S1, and set the info to this. Now we'll display the info, and it displays it. So these functions operate on the student class and will use the private variables to do specific tasks. All right, now let's look at operator overloading. This allows you to redefine the way operators work for user-defined types. So there's this specific example where you have this class vector that you've made, and it's got an x and a y, and you can initialize it by inputting an x and a y. By default, they'll be 0. And then we've overloaded this operator, the plus operator, so that it adds the x's of the two vectors together and the y's of the two vectors together. So the general format of this is you've got the type, so in this case it's a vector. You write operator, and then the symbol you want to overload, and then you take in whatever you need. In this case, we need the other vector, and we'll return a vector of the x's added together and the y's added together. So here we'll test this out. So we got this vector v1, which is 1, 2, and we've got the second vector v2, which is 3, 4. So we create this v3, which is v1 plus v2. So this should be 4 for the x and 6 for the y. And here if we run this code, 4 for the x and 6 for the y, so this works. So that's just an introduction to operator overloading. There's a lot of operators you can overload, like the minus, division, times, I believe. Like there's other ones, the less than and greater than, equals, etc. And all right, let's look at derived classes now. So in C++, a derived class is a class that inherits properties and behaviors from another class, known as a base class. This mechanism of inheritance allows the derived class to reuse the code in the base class and extend or customize it as needed. So inheritance is when a derived class inherits all non-private members, so public and protected members of its base class. And the access control is the accessibility of the inherited members in the derived class depends on the access specifier used during the inheritance. So we'll get to this in a second. And we can customize this. So the derived class can add new members, so variables and functions, override functions from the base class if marked as virtual in the base class, and a derived class represents is a relationship with the base class, so it is of the base class. So the general syntax for derived classes is this. So you've got this class base class, and you've got stuff in here, and you've got this class derived class, a colon, and then access specifier in base class. Generally you would just write public to keep things like as they should be. And I believe by default it's set to public. No, by default it's set to private, so you'll need to change it if you want it to be public or protected. So let's quickly look at what these different things mean. So if you write public in this spot, then the base class public members will stay public, the base class protected members will stay protected, and the base class private members are not going to be inherited. If you write private instead here, which is the default, then everything that's public and protected will become private, and the base class private will not be inherited. If you write protected, it's kind of the in-between. So the base class public will drop down to being protected, and the base class protected will stay being protected. So these are kind of the different ways you can organize it. And now let's look at another example. So you've got this base class animal, and it's got this eat, which just prints out the animal eats food. And you've got this dog that's a public animal, so it's derived from animal. And it's got this void bark, and the dog barks. So you can type in your code dog.eat and also dog.bark, because it's got access to this eat. This is part of the dog. So the animal eats food, the dog barks. You can do both of these. Now if you were to write private, let's see what this does. So this gives you an error, because then it inherits the stuff from animal, but it turns this eat into a private instead of public, and you can't call that from outside the class. So that's where this access specifier comes in. All right, so let's look at encapsulation real quick. So access modifiers, encapsulation uses access modifiers, so private, public, and protected, to control access to the data and methods. So as I've said, private methods are only accessible within the class, protected is accessible within the class and derived classes, and public is accessible from anywhere. So let's look at making copies, assignment, and destructors. So this is where you can control how objects are copied, assigned, and destroyed. When objects are copied or assigned, you may need to define custom behavior, especially if they're managed in dynamic memory. So additionally, destructors clean up resources when an object goes out of scope. I'll paste in this example. So we've got this class, and private we've got this data, and in the public we've got the constructor, the copy constructor, and the assignment operator, as well as the destructors. So destructors have this symbol here, followed by the name of the class. This symbol is to the left of the 1 key on your keyboard. And this is what it does when it goes out of scope and you call delete on this object. Main method, where we create this object with a value of 10. We assign this object to object 1, and we copy it. So we'll display object 2. So it has a value of 10. And then we create this object 3 with a value of 20, set object 3 equal to 1, and then display object 3, and again its value is 10. So you can see the assignment operator assigns the new value to the old one, to the initial one. All right, so now let's look at classes, arrays, and dynamic allocation of objects. So you can dynamically allocate an array of objects or custom classes, or other objects that you've made on the heap. So you do this by using this symbol here, which is Shift 8. So polymorphism is the ability to represent the same interface for different data types. In C++, it allows a common function or name, It allows a common function name or operator to handle different types of objects. So there's compile time polymorphism, which is achieved through function overloading, same function name with different parameters, and operator overloading. And there's also runtime polymorphism, which is achieved through inheritance and virtual functions, where the function to execute is determined at runtime. All right, so we'll take a look at this. So we've got this class animal, and we've got this class dog, and we'll put this in the main. So we create an animal, and we make it a new dog. And when we call a.speak, it outputs the dog sound instead of the animal sound. So this is interesting because, it says woof. You would expect this, since it's an animal type, to access this, but since you've created it as a dog, then it calls the wolf. So this is an example of runtime polymorphism. If we change this to animal and run it, then it will type animal sound. There's also so we'll take a look at another example now just to try to make it a bit more clear. So you've probably seen this classic example. You've got a class person and then you've got a class student that inherits from the person, and each one has an introduce. So this one says, hey, I'm a student because they're a student. This one says, hey, from person because they're a person. This is a farmer from a public person. So, and you have who is this. So when we run this, we can see we have a person, student, and farmer. And when you call who is this, each of them is at base a person, but it calls a different function for each one. So in this case, it will call hey from person, and then hey from student, and then hey from farmer, because it goes in and sees that we've inputted P, which is a student. So it ends up calling this instead of this. So this is the base intro into polymorphism with some examples. That finishes off this video with the basics of object-oriented programming. Thank you for watching and have a great day.